We are coming to page 7, question 4. This is a very important question, so you must try your best to understand the concept behind this question. Find the equation of a circle whose center passes through the 2 points A and B, and the center actually lies on this line y equal to x plus 1. It's tough to see, so as recommended, please do a simple sketch. I'm going to draw my circle. There is a point A and point B that lies on the circumference of the circle. And there's another information that says that the center actually lies on the line y is equal to x plus 1. I'm going to draw that as well. As per previous question, it's always very important that we need to find the center of the circle, the radius of the circle, before we can form the equation of the circle. It seems that none of these are found inside this information given. So, what is the underlying concept? Now, please listen carefully. First, I will need you to join the 2 points together from A to B. Notice, if I were to join these 2 points, again, to the center of this circle, you realize that this is an isosceles triangle. You will have learned previously that in an isosceles triangle, we can actually bisect and cut the isosceles triangle into 2 equal halves. And this is also known as the perpendicular bisector. This means to say, the line that I've just drawn, which is the perpendicular bisector, actually cuts through the center of the circle as well. And in the question, we were also told that the center of the circle actually lies on the line y is equal to x plus 1. The intersection of the 2 lines would allow us to find the center of the circle by solving by simultaneous equation. So, our job is to find the equation of this perpendicular bisector before we solve for simultaneous equation. If you have understood this particular concept, let us get started. Remember, our aim is to find the equation of the perpendicular bisector. But before we can do that, there are a few things we need to find. We will need to find the midpoint of AB. We will need to find the gradient of AB before we find the gradient of the perpendicular bisector of AB. So in that order, let us get started. First, we would like to find the midpoint of AB. Using the midpoint formula, the midpoint has been found. Next, we would like to find the gradient of AB using the gradient formula. Since the gradient of AB is equal to 2, it means that we are able to find the gradient of the perpendicular bisector of AB by using the negative reciprocal of gradient of AB. And this will allow us to have negative half. Now, we would like to write all this into the equation of a straight line. Since the gradient is negative half, our job is to find the y-intercept, which is the value of c right now. And we can make use of the midpoint of AB to do so, since the midpoint actually lies on the perpendicular bisector of AB as well. Great. The equation of the perpendicular bisector of AB has been found. And we were told in the question that the center of the circle also lies on y is equal to x plus 1. Since the center also lies on the perpendicular bisector, we are going to solve for simultaneous equation right now because the center is the intersection of the two lines that I've just labeled. So now our job is to solve for simultaneous equation to find the center of the circle. And find the corresponding value of y. Great. The center of the circle is found to be 2/3, 5/3. We can also find the radius of the circle by finding the distance of this center to either A or B. In my case, I'm going to use point A. Using the distance formula, I'm going to write it in exact form rather than using decimal so that my answers are more accurate later as I express them in the equation of a circle. Center has been found, radius has been found. So now it's time to write the equation of the circle in standard form before we change it to general form. This is the equation of the circle in standard form. Now we will need to do the necessary expansion equate to 0 before we can change them to general form. Now we will need to equate to 0. Make an effort to understand this concept in finding equation of a circle before you are able to do those questions on page 8.